Welcome, students. We are now finally at our last video lesson of week 3 of e-learning. And as we see here at the top of the top left of the presentation that you see here, guys, it says tear out and staple workbook pages 323 through 326. Do not worry about those just yet. I'm actually, again, you guys don't have access to your workbooks, obviously, so I've got my own here, and I'm going to scan them, and we'll do them that way starting next week. So no need to worry about those just yet. But announcements, again, ignore the announcements there. That's from previous academic year. So the announcements go the same as the other day. We've got our quiz, our week 3 unit quiz starting tomorrow. Again, that's due by the end of the week, which will be Sunday. So make sure you access that as soon as you can. You get one time to access it. You get a 1 hour time limit. So take that when you are ready. Complete that as soon as possible when you are ready with your notebooks and such. We also have our lab assignment due this weekend as well. That includes the moon phases lab, which is the sheet, labeling the phases, drawing those on your own, and then answering the few questions that go after that. But let's go ahead and start our Go Blue, guys. Number 1, what exactly causes tides? Number 2, which influences tides more, the sun or the moon? Explain. And that was on the videos from yesterday. Again, my apologies, I'd like to say, because the videos did not have sound on them. I forgot to, usually whenever I record these video lessons, I have to make a settings adjustment that shows that the YouTube videos or the links that I show can have their volume. And I forgot to press that button, so there was no volume on those. But you obviously can easily, you have to watch those on your own anyway in the fullest extent, the entire duration of the videos. So it shouldn't have been too much of a problem either way with the little parts of it that I showed myself. And then number 3, what would happen if Earth lost its moon? So let's think about it. Take a moment to think. Write your answers down on page 8 or 8B or page 9, whatever you guys see fit. But let's go ahead and move on to our answers, guys. Number 1, what causes the tides? Is it the spinning of the Earth? Not exactly. It's going to be the gravitational pull of the moon and the sun on the Earth's surface. So you got both the sun pulling on the surface, which affects, as you can see in this image right on the top right here, this GIF right here, that actually kind of pulls or stretches the ocean, right? It's actually the ocean is fluid, which is going to cause it to be more bendable and stretch with that gravitational pull. And then obviously we see here the moon as well. And number 2, which has a greater impact, the sun or the moon? Despite the sun's larger, massive size compared to the moon actually has a much greater influence due to its proximity to the Earth, due to it being much closer to the Earth. So actually the moon has a great influence. And then lastly, if we remove the moon, what would happen? From yesterday's video, we'd have an improved view of the stars. It'd be nothing but stars in the sky without the moon's glare to maybe kind of, light does kind of prevent us from seeing the stars as well, so an improved stargazing view. And then secondly, loss of marine life and ecosystems. Those tides, again, they're going to be flowing a lot of different food sources, moving a lot of creatures, moving a lot of nutrients all around. And without those tides, there's less movement, which means loss of marine life and ecosystems. Specifically, you're talking about coral reefs, you're talking about crabs, things that are coastline creatures could be at a much decreased amount and rate. And then lastly, weather changes due to changing currents. So where you have warm water flowing and cold water flowing, influencing climate and weather of areas, there'd be less of that to a lesser extent. So maybe drier areas getting drier, maybe humid areas being much impacted. So again, weather changes is our last point being made there. And just to kind of make up yesterday where we left off, what if there was no moon? Again, just to further cement those ideas, let me go ahead and show you guys kind of some of those ideas that I just mentioned there as well.
the next brightest night sky object, Venus. So without it, every night would be as dark as a new moon, and stargazing would be spectacular. But by the next morning, you'd begin to realize just how important the moon is for life on Earth.
Not a good thing.
To start, between the sun, Earth's rotation, and the moon has the largest influence on Earth's tides. Without it, high and low tides would shrink by an estimated 75%. This would jeopardize the lives of many types of crabs, mussels, and sea snails that live in tidal zones.
So you guys get the idea. We should have watched that yesterday. Again, really in depth if you didn't already see it. Just wanted to make sure I made up for the muted segments that I had yesterday as well. All right, let's go ahead and move on to our next topic, next section. Again, stuff today is very brief. The table of contents is the same as yesterday. And this is the last table of contents update for Unit 7. Again, page 10, simply put, moon phases. We're going to go over those briefly today. And keep in mind, again, this is fully up to date with this unit. All right, really quick, for only video questions of the day, this unit does want to go over and kind of gloss over the Earth seasons. So number one, what causes Earth seasons? Number two, what hemisphere is Florida in? I've got a quick video that you guys should watch. I'd probably even recommend only watching half of it. I mean, I think it kind of answers the topics very quickly. And we've gone over it before, but since it's been months since we've gone over it, I did want to go over it briefly again. Here's a little snippet I'll show of that as well. So why do we have different seasons? Again, kind of from a seasons from a space perspective, right?
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun.
So some hints being given there right off the bat, just within the first 30 seconds, to answer at least one of those questions, I know for certain. Okay, again, you guys, I posted those already. Let's go ahead and move on. Got to save time, got to keep my videos as short and as concise as can be. Let's do our first practice question of the day. Which scientific law discusses planet orbital speed increasing as a planet gets closer to the sun due to gravitational pull? And again, we can kind of visualize this through the image on the right here. Again, on your quiz tomorrow, you'll see questions that are very similar to ones we've seen throughout our video lessons this week. A, is it Kepler's second law? B, Kepler's third law? C, Newton's second law? Or D, Newton's third law? Take a moment, think about it. Give it your best guess. The correct answer is going to be A, Kepler's second law. Again, Kepler's second law is going to discuss, anytime you hear anything about orbit has to do with Kepler. So automatically off the bat, you're going to cancel out letters C and D as well. And again, gravitational pull, orbital speed, that has everything to do with second law. Third law has everything to do with orbital length being due to the planet's distance from the sun. Okay, so on page 10, we already wrote down yesterday, if not pause this video, you need to have written down the different phases of the moon. We've done the lab, hopefully already. Just so you guys know, and again, if you're on the videos every day, I want to commend you guys. Awesome job. In fact, this right here, as you're seeing here, this is kind of like an answer sheet for part of that lab, the actual diagram. So if you haven't done the lab already, do yourself a favor, take that out and simply label this as such. It's going to answer the whole top part of that lab sheet that I posted for you guys. So let's just briefly discuss the kind of moon phase terminology. So on the right side, we can see that we have the sunlight, right? And the phases have everything to do with the position of the moon relative to the sun and the earth. So how we view it in relative to the sun, sun's light influencing the moon. So we have all sorts of different moons. We have new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent. Let's start off with the words crescent and gibbous. A lot of you may be familiar with the word crescent. Kind of like when you eat a cookie, right? And you've eaten most of that cookie, there's just a little slither of it left. That slither we obviously call a crescent, okay? And then a gibbous is just the polar opposite of that. So say you've just taken a small bite of it, just the edges of the cookie, or one edge. It's like basically almost a full moon, okay? A gibbous is almost a full moon. Close, but not exactly, all right? Keep in mind, what makes something waxing and waning? Waxing it means that the moon is going to be getting brighter, okay? Waning means that the moon is going to be getting darker as it progresses, okay? Or it's going to be covered in more shadow as it progresses. Where the waxing means it's going to be covered in more light. So on the top of the sheet, you make sure you write this down on page 11 or page 10. It's super important. If it's bright on the right side, you're going to know it's waxing. If it's shade on the right side, it's going to be a waning moon in case it were either of those, okay? So moonlight always moves from the right side of the moon to the left. So this is going to be getting brighter because it's a waxing crescent, okay? New moon is fully shaded. The full moon is, as we all know, is fully lit up, right? And then a first quarter moon means it's going to be a half moon, and that's going to be bright on the right side, shaded on the left. A last quarter moon is going to be shaded on the right, light on the left. So that pretty much runs down the different moon phases. You'll be given blank pictures of these moons, and you'll just have to tell me based on these pictures what phase that moon is in. So super important. Again, if you just understand the ideas at the top here, it'll help you tremendously in the future when you'll see a lot of different moon phase questions coming up. So got to know those guys. Make sure we do. Okay, moving on. Again, lunar eclipse, solar eclipse. Make sure you've already copied these down, obviously. So again, a new moon covered up by the Earth. That's a lunar eclipse. Solar eclipse, which we experienced just a few years ago, when the moon covers the sun, and all you see is a new moon, a shaded moon. That is going to be, again, copied to page 11 with those positions. Practice question number 2. So we just went over the moon phases. Which moon phase is being shown in this image? Is it A, first quarter, B, third quarter, C, waning gibbous, or D, a waxing gibbous? Again, it's almost full, and it's got light on the right side. Think about what we just talked about. Use a chart if you don't know off the top of your head. The correct answer should be D, waxing gibbous. Bright on the right, it's going to be waxing. And then going to be shaded on the right, it's going to be waning. So D is the right answer here. So think about what's the next, if it's getting brighter, what's probably the next phase of this waxing gibbous? That's correct. It's going to be a full moon, full moon. Okay. The only things that I want us to get down for the rest of the day, guys, we're going to talk about 2 different types of tides, spring tides and neap tides. Really quick, though, I did have a quick clip on the phases of the moon, so make sure to watch this on your own from the EDSB post that I've already shown.
But this cycle becomes predictable as the moon's phases repeat every month. The Sumerians, Chinese, and Babylonians depended on the moon's cycle to determine their days, months, and years. And the moon's phases still mark the beginnings of Jewish and Muslim holidays. So what causes the moon to have phases? And why is its cycle consistent? Phases represent the illuminated portion of the moon.
So a great breakdown of historical influence as well as now current calendar influence that the moon plays, especially on the way our month is designed as well. All right, so the last notes of Unit 7, let's go ahead and talk about spring tides and neap tides, okay? So make sure to write these down on page 10. My bad, these are going to go on page 9. Again, just write the title as tides, spring tides, and neap tides. All right, so spring tides, super important to know. These 2 topics, people can make mistakes on if they don't listen carefully and get these down. All right, spring tides are tides that are extreme. So you've got high tides and low tides. And this is because, as you can see down here, you guys should draw this in your notebooks, okay? This is when the moon and the sun align in a linear format, okay? So they're going to be pulling in the same plane on the same direction, which causes those tides to be enhanced. Okay, so higher high tides, lower low tides, going to be more extreme. Okay, again, they're pulling across the same plane. What do you mean by that, Mr. Campbell? Well, let's take a look again. Pause. I'm probably going too fast, so pause as I go along. Neap tides. Okay, think of spring tides like springing. It's like springing up. It's more extreme. But neap tides, it's going to be not as extreme, more moderate in its influence, because we have now, instead of the moon and the sun working in tangent to pull across a linear format, you've now got them pulling on opposite ends at a 90-degree angle. Okay, so now instead of the sun and moon working together to pull the ocean waters on the same plane, they're going to be pulling in different angles, different points of view. Okay, so this is going to cause, like I said, our tides to be more moderate, lower high tides, and higher low tides. So if you know one, simply put, the other is the opposite. Let me go ahead and show my last video clip of the day. And again, we drew these already yesterday. Again, you should have drawn these. Spring tides, it's in a line, right? See the linear format there? And the neap tides, it's in a right angle 90-degree format, okay? So what I do want you to get down, though, for certain is the descriptions. Okay, those are crucially important for our quiz and for future material. Okay, last little clip of the day that explains that, illustrates that. Again, the more examples we see, the better we can know the different topics. Oh, there's that mute again, the mute volume, right?
Sun and the moon are in alignment. The sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides.
So, what we just talked about, right? And the full extent of the entire video, which you should have watched yesterday, is also on EDSB. You got to make our video lessons, keep it concise, right? All right, let's go to our last activity of the day, guys. Last activity, we're almost the finish line for the week. Which type of tide would form from the following sun, moon, earth setups on the right? So we can see here, we've got sun, moon, and earth lining up in a linear fashion, not in a 90-degree angle. So what is the best answer here? What is your best answer? Again, could be on the quiz coming up. A, spring tide, B, neap tide, C, high tide, or D, low tide? Think about it. See what you guys have. The answer is going to be A, spring tide. Again, they're working together. They're working in tangent, which is going to cause those tides to be more extreme. Higher high tides, lower low tides. All right, guys, that concludes video lessons for the week. Make sure to submit your moon phases lab by the weekend, Saturday or Sunday. The only thing I've got tomorrow is our, again, it's assessment day Friday, right? So we're just going to have our quiz. So again, make sure you prepare for that unit quiz. You take it Friday, Saturday, or no later than Sunday afternoon. If you have any questions, guys, message me. Grades getting up to date, as well as I'll be contacting those who have not been active on their unit quizzes. So make sure you get on that ASAP. We're going to be more kind of efficient with grading, and more just, you know, I let the first few weeks of e-learning, I gave kind of a lot of people extra time, and I'm giving a lot of flexibility with that. So as we go along here to week 4, 5, and 6, finishing out for the quarter to 7, 8, 9, we're going to be a little more kind of on it with those due dates, and on it with making sure we get things in efficiently, right? So again, take care, guys. Have an awesome Thursday. And Mr. Campbell signing out. Be ready for the unit quiz tomorrow.